The last two problems are focused on sort of periodic functions described in context and then sort of interpreting what each of those parts of the graphs that we've been identifying on the previous problems represent. So the first one's going back, looking at a Ferris wheel. So if you think about a Ferris wheel is, in a circle. And we're told that this particular Ferris wheel has a 30-meter diameter, so that would be the distance all across, and you board sort of at the bottom of the Ferris wheel, which happens to be 4 meters off the ground. And then, the Ferris wheel travels in a circle, and you're looking at your height above the ground in meters, T minutes into the ride. So you sort of, how high up are you along the ride? Which means when you're at the tallest point on the ride, you would be 34 meters off the ground. When you're at the lowest point on the ride, you'd be 4 meters off the ground. And so you sort of using that idea, we can sort of create a sketch here. Draw in your axes and label, always important. So in this case, my x-axis is going to be labeled, the T units, which is sort of minutes into ride. And we're told that each sort of loop around the Ferris wheel takes 2.5 minutes. So what I'm going to do is I'm going to just sort of sketch out, this is a sketch, so 2.5, and then another 2.5 would put me at 5 minutes, and then another 2.5 would put me at 7.5. And I'm not going to worry about other labels, that gives me a good enough. And then as we mentioned here, that low point, our y-axis is going to be h of t, which is your height above the ground in meters. So height above ground in meters. And we know that the lowest point is that 4 meters, and the highest point is the 34 meters. And your midline should then fall directly in the middle of that, which would be 15, because half of 30 is 15 meters above 4, which would be 19. So I'm going to put a little dotted line here, just like I did on my guide ones on the previous problem. That way I sort of have a sense of where I'm going. Now, going through and sort of creating this sketch then, I know I boarded at the low point, and 2.5 minutes later, I would have made it one loop around, which means I'm back to the low point, back to the low point. Every period I should be back at the low point. Now, in this being a circle, when I'm halfway around, I should be at my high point, which means halfway along between these two, I should hit the highest point on my graph. Halfway through the period, I will hit my high point, and then probably I would bet halfway between those two, I'm going to hit the middle. And we're going to talk more about how later on in this semester, we're going to look at how to actually create a function to describe this situation. But for now, we're focused more on, can we recognize those sort of mins and maxes? Can we recognize what the midline would be and sort of within the context and the period itself, and sort of talk about it. So in the next problem, I'm not going to write out everything in the video, but I'm going to sort of walk through my description of what each of the parts of this graph represents, and then you can sort of check back to the written out solutions to see my written description. All right, so in this one, we're asked to identify midline, period, amplitude, minimum, maximum. So the easiest one to start with is your period. The period here is 2.5 minutes. That's the length and time it takes to sort of make one rotation around on our Ferris wheel. So a 2.5 minute trip around, that's my period. The minimum value would be the low point on the sort of where we board the Ferris wheel at 4 meters. The maximum value would be 34 meters. That's the high point on the Ferris wheel. Now, in this case, and we haven't done a bunch of these, but our amplitude here, that's going to be the sort of distance between the middle and the low point, which we said was 15. And our midline was at 19. So sort of the middle height that you reach is that 19 meters above the ground, and the amplitude is telling us that you're going to go 15 meters above that value and 15 meters below that value. And that sort of is our interpretations of all the parts of this graph. Now, in this next situation, it's a little more complicated. So we have a weight attached to a spring, and basically if you pull down on the weight, it's going to keep sort of, so if I pull down, it would get further away from the ceiling. And then it would bounce back up to the ceiling because it's attached to a spring. And it actually would sort of follow this sort of periodic pattern we see here. Now, keeping in mind, this 16 is further away from, that 16 would be like down here. The 8 centimeters would actually be, up here. And, the weight is fluctuating down and then back up and then back down and then back up, sort of going back and forth. Now, in this particular case, the midline, which is at 12, would be the sort of distance the weight is away from the ceiling where it begins, where, there's no force applied to it whatsoever. You could think of it as sort of the middle height of the weight from the ceiling. And then in 1 second, it goes through one full rotation, where it moves away from the ceiling and then comes back towards the ceiling and then makes it sort of back to that resting position in 1 second. The closest it gets to the ceiling is 8 centimeters away, and the furthest it gets from the ceiling is 16 centimeters away. The amplitude of 4, so we have an amplitude here of 4, is sort of the distance that the weight goes above and below that 12 centimeter resting place. And so hopefully this is just a sort of brief introduction to sort of interpreting parts of our periodic function.